Okay, guys, today we're going to talk about rational numbers. So since this is lesson number 1, let's get some things cleared up right here before we hit the ground running. So remember how we do our 3 different colors? Well, here in my when I do on my online, I don't write it because I use my finger to write, and it's kind of sloppy. So I type everything that I can. So anytime you see black writing or type, that is my definitions, my what's the word I'm looking for? Examples, problems, all that kind of stuff. So anything that I write in that color I write with a lot in class, that's going to be my black, that's going to be my type. I'm going to switch up the colors this time because I'm getting bored. I think I'm going to use purple as my work. And let's go with green as my explanation. And as you can see by my quick little handwriting up there, right here in the corner, it doesn't look too good on my computer. I know that this stuff is not typed for you, so you're going to have to just get used to hitting that pause button, writing down and coming back, or rewinding the video if you need be. I know sometimes you guys are used, you get used to rewatching a YouTube video or watching a Netflix episode because you missed something because someone was talking. But for some reason, it's so hard to do it when you're writing down notes. No idea why. It's not like you can't pause at any time. So please get in the habit of figuring out when you need to pause, when is a good time, do you want to stop and pause at the beginning of the slide or at the end of the slide. That's all up to you. All right, let's get into notes. So rational numbers. What is a rational number? Maybe. There. A rational number is a number that can be written as a comparison of 2 integers, and we know integers are different types of numbers. So my first example is 19%. We can say that 19% can be written as 19 over 100, because 19, the percentage over the total percentage of 100. And again, I'm trying to really work on my zeros. They look too much like 6s sometimes, and I get a little nervous. We can also say that 0.25 is like saying we should be used to that one is a quarter. 3/4 is just 3/4. And 2.5 can be written as a improper fraction by taking the whole number times the denominator, so 2 times 2, and then you add the numerator, so in this case 1. So 2 times 2 is 4, plus 1 is 5, so that gives me 5 halves. So some kind of comparison, so 5 over 2, 3 over 4, 1 over 4, 19 over 100. Now, something I want to talk about real quick before we get into the next slide is the word ratio itself. Excuse me, rational. I jumped the gun. Rational, a rational number. It has the word, I said green, ratio in the first part. And we learned last year, we learned in 6th grade. If you're not sure, go watch my video on ratios. A ratio is just a type of fraction. Just another fancy word for fraction. No reason to get scared of them. Lots of people do because there's just different words. Well, some people can go by different names. Sometimes they go by their full first name. Sometimes they go by a nickname. Sometimes they just go by their last name. Sometimes they go by just their whole name put as one giant word. Same person, different nicknames. Same thing, different words. All right, you're going to want to copy this down. I tried to come up with, my face is kind of in the way. Make that a little smaller. I tried to come up with enough examples color coding wise so that you could tell the difference. Now I understand you only have your 3 colors, but you are at home or theoretically someplace else you can potentially grab more. If not, just alternate your 3 You really only need one extra. A rational number kind of encompasses everything. It's just a fraction. Fractions we know can be written as decimals and percents. Negative or positive, repeating or non-repeating. An integer is a solid number, like we can be -$8 in the whole. We can be -$5, -10, -1. A whole number includes just the number 0, which is why that 0 is kind of just hanging out there by himself. And a natural number are all the numbers that we're used to seeing. So like I have one Post-it note. That is a natural number. That is something I can physically hold. Owing someone $8, I understand I owe them $8, but I can't conceptually see -8 in my head. I can think about going in a hole, but it's not a tangible item that I can hold. And half of a cup, 0.45 of something, 18%. It's kind of harder to rationalize. The half we can see, but like 18% of something, like say you got, this is going to be really bad, but say you got 18% on a test. Well, that number exists. However, I don't tangibly have 18% of my Post-it note. It's a little bit harder to physically hold. All right. Sorry. Long day. Every rational number can be expressed as a decimal by dividing the numerator by the denominator. So top divided by bottom. The decimal form of a rational number is called a repeating decimal. If the repeating digit is 0, then the decimal is a terminating decimal. So here are some examples. So for example, we discussed a half. A half written as a decimal is 0.50000. As a terminating decimal, I can call it 0.5. 4/9 can be written as 0.4444 going on. Technically this way. Sorry, I'm backwards. Going on forever. It does not terminate because we will never hit that 0, that repeating 0. And then 7/10 can be written as 0.7000. And again, terminating can be to 0.7. Now, something that we would do together as a class, but again, you're watching this at home for some odd reason. In different words, define a repeating and terminating decimal. So something about a repeating. I like to say that it never ends. It's the same number forever. Stand that joke right there. No one will probably understand it. Sad day. Terminating. I missed a letter terminating. Decimal means that it stops. It does not continue. Something to that effect. All right, write each fraction as a mixed number. I'm sorry. Write each fraction or mixed number as a decimal. So this is going to be the, yeah, we all hate you, Miss Kimmy, type of day. We're going to actually remember how to divide longhand. I think I'm going to write it more in the middle. So I'm going to take my 5, that's kind of large, and divide it by 8. And you're probably like, why did you write that really long? Because if you notice, my 5 stops here. Well, let's think about this. Can I logically take 5 and split it into 8 pieces off the top of my head? Nope, no, I can't. So we're going to fill in this spot with zeros. Will we technically need all 5 zeros? We'll find out. 5 is just a good number. Now that's not, 500,000. It's just 5. So my decimal point's there. But we kind of make him float. Stop trying to let me type. He's going to kind of float above. Why is it not working? Hey, there we go. And he's going to sit up top now. So we're going to kind of ignore the little guys right there. And we know that's my decimal point. And I don't know what that's doing, so we're just going to leave it. So since 8 can't go into 5, we already discussed that it cannot. Purple. How many times can 8 go into 50? Let's see. Isn't 8 times 6, 48? What are you doing? So I'm going to write my 48 there. Going to subtract like we do. 50 times 50 minus 48 is 2. We know 8 can't go into 2, so we bring down that first 0 and we write 20. All right, how many times can 8 go into 20? 2. 16 times. Sorry, 2. It's just 16. 8 times 2 is 16. 16, 20 minus 16 gives me 4. And I know 8 can't go into 4, so I need to bring it down another 0. Remember, these zeros up here are just in case we need them. We may or may not need them all. We'll find out. How many times can 8s go into 40? 5 times. 5 times 8 is 40. 40 minus 40 is 0. And then I keep repeating my zeros. So 5 over 8 is 0.625. I know. How do we do long division? Probably all like, oh, hey, Miss Kimmy, she's so mean. She's making me do math. Whoops. Next one. -1 and 2/3. Well, first off, in order to divide stuff, we can't have mixed numbers. So we're going to take my 1 times 3 plus 2. I'm turning that into an improper. So 3 plus 2 is 5. So 5/3. And we're going to stick a negative on it, and we'll stick a negative on it in the end. But for right now, we're going to pretend it's positive. We like to work with positive numbers. I know I'm just going to tap that negative on at the end. Call it good. So I'm splitting 5 by 3. And again, we're going to pretend that decimal point's there. I'm just going to write it up top because since I had such a hard time last time, I'm not going to even monkey with it. And then we're going to fill in random zeros. Let's do 5. Why not? 5's a great number. 3 can go into 5 one time. 3 times 1 is 3. Subtract it. 5 minus 3 gives me 2. Now 3 cannot go into 2, so I need to drop down that first 0 of 20. 3 can go into 20, let's see. 6 times, and we get to 18. I'm going to go down just a smidge. 20 minus 18 is 2. Okay, 3 can go into 2, so we need to drop down another 0. 3 can go into 20, wait a minute, 6 times, which gives me 18. Which gives me 2, which gives me 20, which, oh my gosh, we're just going to go crazy. If you start seeing this pattern, and again, I can keep going and going and going and going and going. And I'll do 6 again and it gives me 18, which gives me 2, which gives me another 0, which means I get another 6. I'm never going to change that. So this example, -1 and 2/3, is a repeating decimal. And this repeating decimal is -1.6 with a line over it. we use that line to indicate that it keeps going on and 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 on forever. Trust me, we have had mathematicians who have spent their life's work proving that this is true. And they've probably have hundreds of thousands of pages of saying, look, I've tried this with different numbers hundreds and thousands of times. So please just trust me, unless you really want to work those out. If you want to do, great. Maybe we'll talk about that. Maybe we'll work on some, maybe extra credit. Maybe. Be good practice. But again, that 6 indicates that it is a repeating decimal. And then 3 divided by 4. Oh, I did that backwards. Four cannot go into 3, but how many times can 4 go into 30? Well, 4 times 8 is 32. That's too much. So 4 times 7 is 28. So 7 times. 30 minus 28 gives me 2. Bring down the 0 and I get 20. A really bad 20. 4 goes into 25 times. 4 times 5 is 20, which gives me 0, which means I get more zeros, which means that I get my answer is 0.75. All right. Word problems, yeah. In a recent season, St. Louis Cardinals first baseman Albert, I'm not even going to try that last name, has 175 hits in 530 at-bats. The nearest thousandth, find his batting average. So we're going to be awesome, and we're going to get a calculator out. And we're going to take the amount of times he actually made a hit divided by the total times he went up to go bat. And I get 0.3301886792. And it probably keeps going, but that's all I wrote down. And it's asked to find the nearest thousandth. So this is my tens, my hundreds, my thousands. So you look to the number to the right of him, and you say, is this bigger or is this smaller than the number 5? Since 1 is smaller, we round down. So his batting percentage, or his batting average, was 0.330. Like a hair attacking my eyelashes and my eyes. Okay, this is one of those pause video and come check your own, because yeah, pause video, check it, see what you get. All right, he won 0.167 races. Ouch. All right, now we're going to go backwards and take decimals and write them as fractions. First, what we do is we figure out how many spots after the decimal I have. So in this case, I have 2. I have 1, 2. So I take that number, in this case, that 45. I put a 1, and then I put 1, 2 zeros. 100th spot. Kind of talked about that there. My hundredths, I'm sorry, my tens, my hundreds, my thousands. Tens, hundreds. And then what I need to do is I need to simplify. So I ask myself, what can divide out of both pieces if possible? It is possible. I can divide both by 5. 45 divided by 5 is 9. 100 divided by 5 is 20. 9 and 20 cannot reduce any farther. So my answer is 9/20. This one, a little bit harder. I need to pick a favorite letter. I don't care what letter it is. I'm going to use the letter V. V. So I have this favorite letter because I like weird letters. Why not? How often do I use the letter V? Use a bunch of other letters all the time. I like this one. And what am I going to do with this favorite letter? And I think I'm going to retype this, honestly, because it kind of looks a little not so good. It looks a little not fun. Lowercase v, not capital V. So what we're going to do is we're going to let it, because this is a cool part about math. We can change and play around with stuff whatever way I want to. And you're probably like, well, why? 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 The cool answer is because I can. Just like when your parents say, well, why can't I do that? And they respond with, because I said so. It's kind of the same thing. That's one of the reasons people don't like math, is they don't understand the different ways to manipulate a function or a problem or anything. And so when people start doing it and they're just like, well, why? Because I can. I can. I want to. I'll go through into more of an explanation of why we're doing this once you see what we've done. It makes a little bit more sense after instead of before. So we're going to let V be the length. We want to, see, real good. Set 0.5 repeating to. I need to write a little line over this because I can't do that on my keyboard. Now, remember, so it's like a big star thing. 0.5 repeating with a line over it is equal to 0.55555555555 forever. Forever. The reason we're going to determine its length is because we want to shorten it. So that way we can play with it and manipulate it. Let's say we're going to make it 4 lengths long. So 4 to 5 is long. So V is equal to 0.1555. I was going to count 1, 2, 3, 4, but if I started doing that, I was kind of afraid we might actually write 1, 2, 3, and 4. Next, again, I'm going to type this. We're going to multiply both sides by 10. The reason we're multiplying both sides by 10 is we only have one number that's repeated. And we're going to multiply by factors of 10 depending on the amount of numbers repeated. So if I had 2 numbers repeated, I'd multiply by 2 factors of 10, which is just 100. If I had 3, I'd multiply by 1,000. If I had 4, I'd multiply by 10,000, so on and so forth as we keep going on. So I'm going to multiply both sides by 10. Because what I do to one side, I do to the other. Now, there's letters. Ah! We just stick them together. This gives me 10 V's. That's all that is. 10 of something, my favorite letters. Multiplying by 10 over here on the right side, though, where's my mouse? There we are, means that my decimal point will move 1. So it becomes 5.5555. Because remember, we said V was still equals to 4, so we need 4 of them. Now, it's kind of a long problem. Now, my original equation. Okay, well, we said my original equation was this green guy. I'm going to duplicate him. I'm moving down here. I'm going to move this a little bit. So we're going to say minus this. And what I do to one side, I do to both. And I'm going to put this over to the side so you can see what I'm doing as I'm doing it. So what's left over? Well, 10 minus 1, because there's an invisible 1 here, gives me 9. That cancels out, that cancels out, that cancels out, that cancels out. 5 minus 0 is 5. So the reason we subtract this and we let it be equal to some crazy letter, I picked V. Do you have to pick V? No. I don't recommend an S, and I don't recommend O. Or T, depending on how you write. I don't recommend those 3 letters. Those are the hardest ones to confuse for other numbers. Any other letter, I don't care. Your choice. The reason we did it is because now we no longer have a decimal, and we can finally solve for my fraction. By allowing to select a specific length, we said 4, and subtracting that off, we can reduce this down. I need to get that favorite letter on my side. Right now he's getting multiplied. Remember, we multiplied him with 10? Now I no longer have 10 anymore, but I have 9. But he's still multiplied. So to undo my multiplication, I'm going to divide both sides by 9. Oops, I said the word divide and I wanted to write D for divide. I don't recommend lowercase a's either. Lots of people get those confused with 9s. 9 divided by 9 is not 1, so I'm left with 1 or 1v. Gives me 5 over 9. Now, I know you're like, no way, there's no way that works. No way. Nope, nope, nope. Grab your closest calculator. I'll even do it on my phone so I can prove to you that it works. Get out your handy dandy calculator part and take 5 divided by 9 for me. Isn't that my original one? Wouldn't you agree? That decimal? This is a lot more complicated than you think it is. You wanna know what I did? I just hit 5 divided by 9. I hit equal so you couldn't see my problem anymore. I know, it's so crazy. You wouldn't think that that much work would give me a fraction or that division problem, but it does. When in doubt, always check your work. Okay, I want you to try this. I'll start this one with you, and then I'm going to have you finish it on your own. So same steps. We're going to pick a favorite letter. I don't care. Let's change it up. Let's do N. And it's going to be 2.18, 18. I mean, you can have more variations of it. I think 4 is a solid number. Let's stick with 4. Let's not go crazy. Let's not do 5 this one. Let's do 4. We already have enough numbers. This is going on. Now, because I have 2 numbers that repeat, instead of multiplying by 10, I'm going to multiply both sides by, I don't want the repeating part. Go away. I'm going to multiply both sides by 100. Remember, we talked about that, but when we started the other problem. This gives me 100n is equal to, well, if 10 moved it over 1 place, 100 moves it over 2 places. So 218.12. Now I'm going to take that purple guy again. And I'm going to subtract him off. Ooh, I don't want to, oops, that's not what I wanted to do. Undo. I'm going to copy him because he still exists. I don't want to delete him. Ooh, I'm kind of close. I'm trying to line up my decimal points. It doesn't really work out too well. And I'm going to subtract him from both sides. Again, I'm trying to line it up. I'm sorry. Doesn't exactly fit. Gone, 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 gone. 218 minus 2 is 216. 100 minus 1, 99. I lied. I said I wasn't going to do it with you, but I'm sorry. I lied to myself. Couldn't help it. We're going to divide both sides by 99. We get n is equal to 216 over 99. You're like, whoa, 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 whoa. Hold the phone. That's improper. You're correct. It is improper. We need to turn it into mixed. So how many times can 99 go into 216? Well, let's think about it. 99 is about 100, correct? And 100 plus 100 gives me 200. So at least goes in 2 times. What is 99 times 2? Let's find out. 9 times 2 is 18. 9 times 2 is 18 plus 1 more is 19. So 198. So 216 minus 198. Oh, I should do this in a linear fashion. I'm going all over the board. I'm sorry. So 216 minus 198. 6 minus 8, well, that doesn't work. So turn this into a 16. 16 minus 8 gives me 8. 0 minus 9, can't do that. So borrow. 10 minus 9 is 1, and 1 minus 1 is 0. So I have 18 left over. So we said it went in 2 times. And we had 18 left over out of 99. Well, then you're like, well, hey, I can reduce this fraction. 9 goes into both of those. The 2 doesn't change because it's not the fractional part, it's the whole number. 18 divided by 9 is 2, and 99 divided by 9 is 11. So my final answer is 2 and 2 over 11. These 2 are your practice on your own. I know I had practice on your own. I couldn't remember which ones they are. These 2 are your practice on your own. I'll give you a hint. This one is a little bit easier than this one. This one looks really close to this one. So use that last problem to help you out. Pause the video, get to work. All right, those should be your answers. If not, let me know. Have a great rest of your day, guys.